right, now let's start today's tutorial. We still have last week's tutorial, the open-ended questions. So we'll start doing last week's open-ended questions first. All right, then we will do this week. Is that okay? All right. Okay, so let me click on the PowerPoint slides and share it with everyone. Okay, right. Okay, I'll skip all these. I went through this. We'll jump straight to this. All right. This is from last week's worksheet. Okay, because we didn't have time to do this. So there are 4 materials. All right. Material A, material B, material C, and material D. They are all of the same size, same thickness. All right, for a fair test. All right, so this is for a fair test so that you have a fair experiment. Otherwise, the results will not be valid. Okay, so same thickness, so therefore a fair test. Everything must be same. Same size, same thickness, all right, just different material. So they were placed in 4 different containers for 5 minutes. So inside each container, there's 100 ml of water, milliliters of water. So the table below shows the amount of water left in the 4 containers after the materials were removed. All right, so some of these materials will, now what is a magical word that anybody can tell me? What water? What is a magical word that starts with M? All right. Okay, Avon, no worries. Then you can watch your YouTube videos. All right, so what is the A word? A, B, anybody knows what word I'm thinking of? The water goes into the material. So I say that the material can what water? Anyone?
Absorb.
Thank you very much. All right, good job, Wen-Xing. The spelling also perfect. Good job, Claire. All right, it's all perfect spelling. Absorb. So you need to talk about absorb water. So some materials can absorb a lot of water. Some materials does not absorb any water. Okay, so take note that this one is talking about amount of water left. All right, so let's now switch to amount, all right, of water absorbed. Okay, absorbed by the material. All right. So can you now tell me, everybody you take your chance. Okay, we start with Avon. Avon, oops, it jumps the slide. Avon, can you tell me for material A, how much water was absorbed by material A? I can't hear you. Again, please.
60.
No, 60 is not right. So good try, but then watch. This is the container. At first, it has 100 ml of water. Okay. Then after I put in this material, right, this material A, it absorbs some water. All right, some of the water, then I take out the material. Okay, then I take out this material. So this material become wet. Then the amount of water left was 60 ml. Okay, after I take out the material A. So can you tell me how much water is absorbed by this material? At first, I have 100 ml of water. Then after that, I put in this material. This material absorbs some water. All right, so some water goes inside the material. Then I take out the material. Then the amount of water drops to 60 ml. So how much water was absorbed by this material A? All right, good job, Evan. Okay, good job, Wen-Xing. The rest we all know. All right, so it is 40 ml. Right, how we get 40 is 100 minus 60. So we get 40 ml. All right, so next, Jane, would you like to try for material B? How much water was absorbed? Material B, how much water was absorbed by material B? Claire, are you there?
Yes.
Okay, how much water was absorbed by material B? For material B, the amount of water left is 40 ml. So how much water goes inside the material? If you're not sure, tell me not sure, okay? Or you don't know how to do this, just say don't know, so that I can help you. Claire, do you know how to do this? I'm not hearing from
60.
Claire. Yes, how do you get 60, Claire? So you use 100 minus 40, right? That will give you 60. Okay, so 60 ml of water was absorbed by the material. You're able to follow? Let me know if you're not able to follow so that I can help you. So what I'm saying is, all right, do not get mixed up with between the word left and absorb. Here you got 40 ml water left, all right? That means the material actually absorbs 60 ml. 40 plus 60 give you back 100 ml. That means out of 100 ml water, the material absorbs 60 ml water. That means 60 ml water go inside the material. All right, and then the material was removed. Together with 60 ml water was removed. So what is left? Left means remaining inside the container. What is left will be 40 ml water. All right, is that okay, Claire? Not, you don't understand, please tell me you don't understand in the chat. All right, don't be shy. You can still tell me you don't understand so that I can explain further. All right, then how about C will be, let's move a little faster. 100 minus 90 will be 10 ml. All right, so 100 minus 20 would be 80 ml. Is everyone clear? All right, so looking at this, right, material A absorb 40 ml of water. That means 40 ml of water go inside material A. Material B absorb 60 ml of water. Material C absorb 10 ml of water. Material D absorb 80 ml of water. All right, so when they tell you left, you must change to absorb. All right, so amount of water left in the container, you will take the original volume of water is 100. 100 minus whatever amount water left, that will tell you how much water was absorbed by the material. Okay, so based on this, which material absorbed the most amount of water? So all right, so which material absorbed the most amount of water? That will be 80. 80 is the biggest number. All right, so material D absorbed the most amount of water. All right, so I will explain this way, material D, because the least amount of water was left. All right, so it has the least amount. 20 is the smallest number. It has so little water left. That means material D absorbed the most water. A lot of water go inside material D. So what is left in the container is only left 20 ml water. So use the word least. All right, cannot use less because you're comparing so many. If you compare 3 and more, you use least. If you're comparing only 2 materials, then you use less. Any questions so far? Okay, then based on this table, which material is most suitable for making a swimsuit? Everybody tell me which material will you use to make the swimsuit? A, B, C, or D? All right, everyone, type into the chat, please. Type into the chat which material will you use to make a swimsuit? Will you use A, B, C, or D to make a swimsuit? Okay, I don't have an answer. Boys and girls, are y'all still thinking? I only have one answer from Claire. Claire, hang on. Even just type once. Don't have to type so many times. Okay. Okay. Right now, some of you, now let me show you what you will do. Whenever they ask you to choose, you either choose the smallest number, all right, or you choose the biggest number. Okay, so either C or D. Don't choose A, don't choose B. Even if you don't understand the question, you can make a wild guess. It's either C or D. That means you either choose the smallest number or biggest number. Understand? That is the exam trick. This is the examination trick. You either choose the smallest number or you choose the biggest number. So the answer could be either smallest number or biggest number. All right,
Why?
because it's the most suitable. So which one do we choose? All right, remember just now we said amount of water absorbed. How much water was absorbed by the material? Okay, absorbed by the material. So 100 minus 60, everybody unmute yourself and tell me this. We went through this just now. So if 60 ml of water was left, how much water was absorbed by the material? So this one is what? 100 minus 60 is 40. Then 100 minus 40, the next one is
60.
60. 100 minus 90 is
10.
10. 100 minus 20 is
80.
80. All right. So you will know how much water is absorbed by the material. When you wear a swimsuit, do you want your swimsuit to absorb a lot of water?
Yes.
If you want your swimsuit to absorb a lot of water, then imagine I ask you to wear a towel. Wear a towel and jump into the swimming pool. Is it easy to swim? Imagine you wrap yourself in a towel, then you jump into the swimming pool. What will happen? The towel will absorb how much water? A lot or very little? Towel will absorb a lot of water, or the towel will absorb very little water?
A lot.
A lot of water, very good. So the towel will absorb a lot of water. Wouldn't you be very heavy? Then it's very hard for you to float, right? So it's not a good choice to wrap yourself with a towel and jump into the pool. All right, because towel or any t-shirt will absorb a lot of water.
But it's also illegal to wear towel to go swimming.
Yeah, of course. Yes, it's not legal. Okay, so we do not want. Okay, so we do not want the swimsuit to absorb water. We do not want the swimsuit to absorb water. So some of you forgot this. All right. We don't want the swimsuit to absorb water. If the swimsuit absorb water, water has mass, right? Then the swimsuit will be very heavy. Then you will sink in the water instead of floating on water. So we don't want swimsuit to absorb water. That's why if you look at your swimsuit material, right, it doesn't absorb water. Not like your t-shirt. Your t-shirt absorbs water, right? Your towel absorbs water.
If our swimsuit don't absorb water, why is it wet?
It's wet because of the layer of water outside the swimsuit. It's not going inside the swimsuit. It's a very good question from Evan. Thank you for asking that, Evan. All right, swimsuit looks like it's very wet, but actually the amount of water is outside the swimsuit. It's not inside the swimsuit. Clear? All right, so if you still find it hard to understand, you imagine you take a piece of handkerchief. All right, a piece of, imagine you're wearing a swimsuit that's made of t-shirt. Then after going into the swimming pool, you can squeeze your t-shirt and then a lot of water will come out from the t-shirt, right? But if you try doing it on a swimsuit, right? You squeeze water from a swimsuit, there will not be much water coming out. All right, so the water doesn't go inside the swimsuit. The water is just outside the swimsuit. The swimsuit does not absorb water. Okay, swimsuit, just like your raincoat. Do you want your raincoat to absorb water? Let me ask everyone. Everybody answer this question in the chat. Do you want your swimsuit? Do you want your raincoat to absorb water? It's raining heavily. You're wearing a raincoat. Do you want the raincoat to absorb the rainwater? Everybody type into the chat. Thank you, Evan. The rest, can I have a response, please? Thank you, Wen-Xing. Do you want your raincoat to absorb water? Do you want your raincoat to absorb water? Jane, what is your answer? I don't have an answer from Jane. Jane, are you there? Jane and Wen-Xing, Wen-Xing, I can see a reply, thank you, even though I don't see your face. But Jane, I don't see your face and I don't see an answer on the chat. Are you there, Jane? Do you want your raincoat to absorb water? Do you want your raincoat to absorb water? Jane? Jane, I'm waiting for an answer. Thank you, Jane. So we do not want our raincoat to absorb water. So in the same way, we also don't want our swimsuit to absorb water. So which material will you choose for this question? Therefore, you will choose C or D. Which one will absorb? Which one will you use, everyone? C or D?
Yeah.
So the answer is C. Because C only absorbs 10 ml of water. Okay. Material C only absorb 10 ml of water. Material D absorb 80 ml of water, so much water. P only absorb